Hey y'all, and welcome to week 6 Tiny Desk Talk of Will She Finally Blow Up Her Room? The answer is most likely not, but there's always time to find out. Just kidding. So, guys, we're in week 6, so as we are wrapping up the end of the week, today's interactive discussion is going to be about nuclear bombs, which obviously I don't think okay. Except for maybe some lithium ion batteries floating around somewhere, which as long as I don't superheat, I don't have anything explosive in my room. Pretty sure. But but this week we are talking about nuclear bombs and how they work. So if you're like me or anything like me and you grew up on cartoons, so the first thing I thought of was the Illudium PU-36 that Marv the Martian was always looking for. But if you're not me, then maybe you don't get that reference, or if you just never watched Looney Tunes, I feel sorry for you. But anyway, just as a quick reference to my childhood.
Pardon me again, Doc, but just what did you mean by that crack about the Earth being gone?
I'm going to blow it up. It obstructs my view of Venus.
It does? That's a shame.
Where's the kaboom? There was supposed to be an earth-shattering kaboom. The Illudium PU-36 explosive space modulator. That creature has stolen the space modulator.
So yeah, that was the first thing that I thought of. Obviously, we are not in cartoons and we're not using nuclear bombs to blow up the Earth, although theoretically we could. Although the people who are trying to test that theory might blow themselves up before that ever happens. Who knows? Anyway, so to get down to business of how nuclear bombs work. So earlier in this week's chapter, we kind of read about how one of our most unstable, and granted, initially we were talking about it in terms of being, in terms of radiation exposure, we were talking about uranium. So in terms of nuclear science and nuclear explosions, and in this case, nuclear bombs, one of the two different types of nuclear bombs, so we have our atomic bomb and then we have our hydrogen bomb, is for the atomic bomb, which both use nuclear atomic atoms, but the atomic bomb uses uranium, specifically uranium-235, which is highly unstable, to execute its nuclear explosive reaction. So again, to kind of backtrack on myself, the basics of nuclear bombs is that both hydrogen bombs and atomic bombs use nuclear atomic atoms that with enough stimulation will use nuclear fission, not fusion, fission, as a means of creating combustive or explosive energy in the nuclear bombs that we know and love. The most famous, at least in the US standards, being the bombs that were dropped on Nagasaki and Hiroshima back in World War II. Not the best in US history. Actually, there's a lot of things that go into not being the best in US history, but anyway. So, as mentioned, the difference between the two, between the atomic bomb and the hydrogen bomb, is that the atomic bomb kind of separates what is known as the critical mass needed for uranium-235 or plutonium, I believe it's plutonium-39, or plutonium-39 to have that nuclear reaction. And so I'm going to actually reference the textbook real quick and show you kind of a diagram image of basically this, where you have basically the critical mass is broken up into two and can obviously be broken up into more than two chambers. But basically, dividing the critical mass until it gets to a point where a set detonator or set explosive causes the two or the separated however many masses to combine into the necessary critical mass to create that nuclear fission and thus the explosion. And if you remember from our textbook, the nuclear fission is essentially the starting point of what can become a series of chain reactions as our unstable nuclear molecule tries to achieve stability through these exothermic combustive reactions. So, uranium-235 will break off into smaller and slightly more stable particles, and it will continue breaking off into particles until it achieves or attempts to achieve stability. If you remember back in chapter 21 when we read about that. So that's basically what's happening whenever we initiate a nuclear explosion using a nuclear bomb, is that we are initiating that series of reactions to create that large combustive product that can also lead to not only a physical heat explosion or chemical heat explosion, but also causes radiation, which anyone in Japan who was anywhere near the sites of Hiroshima or Nagasaki could probably tell you firsthand suffered severe radiation burns, radiation poisoning, and many often got cancers. So, not good all the way around. And then our second type of bomb is our hydrogen bomb. And our hydrogen bomb usually, let me refer to my notes real quick. Okay, so our hydrogen bomb actually refers to a thermonuclear fusion reaction, and so basically it relies on the combustion reaction to initiate a larger combustion reaction. And I know it's called hydrogen bomb. The two atoms that are actually used for a hydrogen bomb, which are hydrogen equivalents but not hydrogen, are deuterium and tritium. I don't know. Don't ask me to pronounce things. I'm from Texas. Anyway, so the deuterium and the tritium usually combined with, again, which is why I mentioned earlier, the only explosive things I have in my room are my lithium batteries in my technology. So the deuterium and the tritium are usually combined with lithium hydride and then an integrated nuclear device, aka the detonator, which will trigger the thermonuclear reaction, thus causing the grand explosion of, again, still nuclear, but just a different type of nuclear explosion. So I think the only thing I forgot to mention is that the power of nuclear bombs is measured in TNT, which is, the dynamite that we typically know as a standard unit of measurement. So basically, we go by the equivalence of, 2.0 times 10 to the 13th TNTs of, explosive energy that can be produced by a bomb. And so because it would take essentially that many sticks of dynamite to create that same reaction versus however many grams of, uranium molecule that we're using in our atomic bomb, or the deuterium that we're using in our hydrogen bomb. I believe that covers everything that I have in my notes for this week's discussions. Any comments, questions, concerns that you may have, feel free to leave a comment. But until then, I will see you next week in our closing, second to last episode of Interactive Discussions. Bye.